msnbc.com. Welcome to another MedCram COVID-19 update. Today we're going to talk about PAXLOVID. PAXLOVID has been given emergency use authorization for COVID-19. And we're going to ask today, how does it work? Who is it for? And what's the evidence? PAXLOVID is one of the first oral medications that's been given emergency use authorization from the FDA to reduce hospitalizations and death from COVID-19. But to understand how PAXLOVID works, we have to understand how the virus infects and reproduces in the human cell. So let's take a look at the human cell. And here's the cell membrane. And here we have the nucleus. Here's the SARS-CoV-2 virus. And of course, we know that inside of it is a very long messenger RNA that holds the genetic code for the virus. The virus will bind to the ACE2 receptor on the surface of the cell. And when it goes inside, it will release its messenger RNA. Now, this messenger RNA is then translated by the cell's ribosomes into proteins. And specifically, it will translate it into a fairly long protein here that we've drawn out. Now, that protein has to be cut up into pieces using something called proteases. These proteases are also coded for on the messenger RNA and translated by the ribosomes. So in other words, not only is this long protein here in orange a product of the messenger RNA, but so are these proteases that come around and actually chop up the proteins. Now, this long protein then turns into smaller proteins, which are important because these smaller proteins can come together and form something called a replicase, or a RNA-dependent RNA polymerase. And that's important for the virus because it's this protein that will then produce more messenger RNA for the virus so it can be used in repackaging and making more viral particles. And so you can see that a very important step here is the protease from the virus chopping up the protein product to make these very important protein fragments that will be used in the replication process. If we can somehow shut down the ability of these proteases, then these replicase proteins will never be made and viral replication will cease to happen. And that's exactly where PAXLOVID works in this process. You see, these proteases recognize very specific points along these proteins where it cuts it. And what PAXLOVID does is it mimics this pattern exactly where these proteins need to be cut up, and it binds to these proteases and prevents the proteases from working. And these, generally speaking, are known as protease inhibitors. And as it turns out, the specific protease that PAXLOVID inhibits is responsible for 11 different cleavage sites along that protein. And cleavage sites are basically where proteases normally cut up the proteins. Now, if you're interested in the biochemistry and the organic chemistry of the synthesis of PAXLOVID, I'll put a link in the description below to a video that goes into that in more detail. But as you can see, PAXLOVID, which is a protease inhibitor, blocks the protease action very early on in the infection. In fact, it prevents replication of the virus. And so you can see that if started early enough, this could be a very powerful medication. One of the problems that scientists had had for a long time with protease inhibitors in general is that protease inhibitors are metabolized by something known as the P450 system. And don't be too scared by this technical term. The cytochrome P450 system is simply a metabolism system in the body that metabolizes and breaks down foreign substances like medications and other things. And it's important in this case because specifically the active medication in PAXLOVID is metabolized by this system. And because of the P450 system, which predominantly works in the liver and also in other places in the body, protease inhibitors don't last very long in the body because the body breaks it down. And so one of the things that scientists have done to increase the efficacy of protease inhibitors is to add a medication which will block the breakdown of the protease inhibitors. And the medication which has done this over and over again in multiple drug combinations with protease inhibitors in the past is a medication known as ritonavir. In fact, PAXLOVID is actually a drug combination of nirmatrelvir and ritonavir. You may notice that both of the medications in PAXLOVID end in VIR, and this is generally the suffix that's given to medications that have antiviral activity. The first component, nirmatrelvir, is the actual protease inhibitor, whereas ritonavir is the portion of the combination that keeps the protease inhibitor at a relatively elevated concentration so it can do its work. One of the things that you have to be careful of with this combination of medication of PAXLOVID is that ritonavir can also cause other things to become elevated because the P450 system metabolizes a number of things. There are different sections to the P450 system, and the system specifically that is involved with PAXLOVID is the 3A4 portion of that P450 system. And that's helpful because you can see other medications that specifically go through the P450 3A4 portion and know that ritonavir is going to inhibit the breakdown of those particular medications, and not other medications that also go through the P450 system but not the 3A4 area. So now that you know what nirmatrelvir and ritonavir do, the question is what's the evidence for the efficacy of this in human beings in a real-world example? So let's talk about the Pfizer Phase 2 and Phase 3 trial for this medication, PAXLOVID. This is the data that was submitted to the FDA for emergency use authorization. This data is coming from Pfizer, and we look forward to a peer-reviewed publication of this data. And I have no financial disclosures with Pfizer. What we're going to do is simply look at the data. So the first thing we need to do is define what a dose of PAXLOVID looks like, and also ritonavir. And in this case, when a patient opens up a dose of PAXLOVID, they're going to get 2 tablets of the nirmatrelvir, each 150 milligrams, and they're going to get 1 tablet of the ritonavir at 100 milligrams. So there's actually 3 tablets in 1 dose. And again, as we said, the ritonavir simply is there to increase the concentration of the nirmatrelvir. And what they set out to do was to actually enroll 3,000 subjects on 5 different continents, including the United States. And what they set out to do was to do a randomized, placebo-controlled trial, which was double-blinded. And so the type of patient they were looking for is very important to understand. First off, they had to be SARS-CoV-2 positive. They had to have mild or moderate symptoms. The mild and moderate symptoms are defined in the study, but basically patients who had symptoms that did not require hospitalization and did not require supplemental oxygen for less than or equal to 5 days. They could not have been hospitalized. So these are patients that are not sick enough to be hospitalized. And they have to be 12 years of age or older. They must be at least 88 pounds. That's about 40 kilograms. And they must have at least 1 risk factor that predisposes them to advancing to more severe disease. People with advanced age, diabetes, cardiovascular disease, and other things that could lead the patient to progression and worsening of their COVID-19 symptoms. So in the study, they planned on getting 3,000 subjects, but as it turns out, because the drug was so efficacious, the Data Safety Monitoring Board stopped at only enrollment of 1,219. And this pausing of the study is something that is planned at the beginning of the trial, and that is to show that if the endpoints are met, then they don't want to continue to give patients in the study placebo when they know that the intervention is effective. And that's exactly what happened here. But what they did was they randomized them into 2 groups, those with PAXLOVID and those for placebo. And of course, this was double-blinded, so they didn't know what they were getting. And the key here that you should understand is it was an oral medication. This is different. This is not a monoclonal antibody that has to be infused. This is an oral medication that can be given to a patient without having them be admitted to an emergency room or an infusion center. As we talked about, it was 3 tablets, and it was given every 12 hours times 5 days. And of course, the same in the placebo group, who got theirs. And I really want to divide the results into two different categories. There were those that had symptoms less than or equal to 3 days prior to starting either placebo or PAXLOVID. And there were those that had symptoms less than or equal to 5 days. And the inclusion criteria, which is basically the criteria that allows patients to enter into the study, were those that had symptoms for equal to or less than 5 days. And in the PAXLOVID, there were 607 total subjects. In the placebo, there was 612. But if we narrowed it down and looked at a subgroup analysis of those that got to them early enough at less than 3 days, it was 389 in that group and 385 in the placebo group. Now let's take a look at hospitalizations and deaths in each of these groups. In the PAXLOVID group, those that had symptoms for equal to or less than 3 days, there were only 3 people that were hospitalized in that group. In the placebo, there were 27. If you look at as a percentage of the total, this works out to be 0.8% in the PAXLOVID group, and in the placebo group, it works out to 7%. Which means, in terms of hospitalization, there was a 89% relative risk reduction in that group. And by relative risk reduction, what I'm saying here is, what are the chances that you would have hospitalization if you took PAXLOVID versus placebo? If you look at the absolute risk reduction, it turns out to be 6.2%. The absolute risk reduction is how much risk was absolutely gotten rid of based on the actual risk, not relative to what the risk was for placebo. As you can see here, the 89% relative risk reduction meant that you went from 27 down to 3, or you went from 7% down to 0.8%. That was an 89% relative risk reduction. The absolute risk reduction, however, is numerically what's the difference between 7.0% and 0.8%. And that actually has more overall significance in terms of rare diseases versus common diseases. And the number needed to treat is the reciprocal, or the flip, of the absolute risk reduction. This is important because the number needed to treat tells us how many patients we would have to treat to prevent one person from having an adverse outcome. The higher the absolute risk reduction, the lower the number needed to treat and the more powerful the intervention. The lower the absolute risk reduction, the higher the number of needed to treat, the less powerful the intervention. In this case, the number needed to treat was 17. That means that if you treated 17 people in this category, you could prevent 1 hospitalization. And that's not a bad number. And to give an example of other medications that have number needed to treat, for instance, if you were to look at a statin drug and how well it could prevent either a heart attack or a stroke in an individual over the next 5 years, the number needed to treat there is generally around 16. So you'd have to treat 16 people with a statin drug for 5 years to prevent 1 stroke or heart attack. What about deaths? Well, in the PAXLOVID group, if you got to them before the end of 3 days of symptoms, there was actually 0 deaths in that group, and that's, of course, 0%. But in the placebo group, there were 7 deaths, and that's 1.8%. Now, of course, if you look at this, that is a 1.8% absolute risk reduction, and the reciprocal of that would take us to a number needed to treat of 56. But I would caution that this study was stopped early, so the number of deaths in the placebo group could have gotten higher, and therefore this absolute risk reduction could have been greater, and therefore the number needed to treat could be lower. By the way, in terms of these two groups of numbers, the p-value was less than 0.0001. Okay, now let's look at the 5-day data. Now, obviously, if we're waiting longer to start the intervention or the treatment, the numbers are not going to be as good, and that's what we see here, but they're still pretty decent, because when we look at those that got PAXLOVID, within 5 days, there were only 6 hospitalizations in that group, and that worked out to be about 1%, whereas those that got placebo, those that were hospitalized, were 41 in there, and that's 6.7%. That's 85% relative risk reduction, with an absolute risk reduction of 5.7%, giving you a number needed to treat of 18. So in other words, if you wait too long to treat them, instead of 3 days, go up to 5 days, you have to treat one more person to save a hospitalization. In terms of deaths within 5 days, again, there were 0 deaths 28 days out in the PAXLOVID group when treated within 5 days of symptoms. In terms of placebo, in that group, there were 10 deaths, giving you a percentage of 1.6%, and a 1.6% absolute risk reduction would give you a number needed to treat of 63. Again, I would use the same caution. This number here of 1,219 was where the study was stopped because the Data Monitoring Board looked at the data and said that we really could not ethically continue this study because there was a difference, a dramatic difference in terms of the efficacy between PAXLOVID and placebo. So how do we look at this data? We would say that when given within 3 days of mild to moderate symptoms in patients who are candidates for treatment, PAXLOVID was able to reduce hospitalization rates by 89% in terms of relative risk reduction. When given within 5 days, that number dropped modestly to 85% relative risk reduction. So it's good to know that a medication is effective. The next question, of course, is it safe? So what we have to go off of is basically the release from the Pfizer website, which we'll give you a link to in the description below. But in terms of adverse events after the treatment was started, we see that in PAXLOVID, this was around 19%. They say that most of these were mild. In placebo, it was 21%. Now, in terms of serious events, there was 1.7% that had serious adverse events. They didn't define what those were. And in the placebo, it was 6.6%. So there's actually more serious events in the placebo group than there was in the PAXLOVID group. And again, this could be because the medication is so effective at reducing hospitalization that these adverse effects may have come from hospitalization. In terms of discontinuation, the discontinuation rate when patients were given PAXLOVID was 2.1%. Placebo was 4.1%. Again, similar reasoning here is that if the patients are progressing towards hospitalization, they may ascribe some of the events associated with hospitalization to the medication intervention that they're taking, whether it's placebo or PAXLOVID. And because more patients went for hospitalization and death in the placebo group, that may be the reason why the numbers on the right are higher than the numbers on the left. So you can see why it's important to do these kinds of comparisons between the intervention and the placebo in terms of adverse events, serious events, and discontinuation. Because it's very difficult to tell when someone is going through an illness whether or not the effects that they're feeling is from the medication or from the illness. And so it's possible that a lot of the effects that people are feeling occasionally may be actually related to the illness. So as you can see here, there were a considerable amount of side effects related to placebo, which would seem to indicate that PAXLOVID is very well tolerated and has minimal adverse events, serious events. Okay, let's talk about availability now of this medication. So remember that it is predicted with Omicron in 2022 that we may be seeing up to 1 million new cases a day. And Pfizer is stating that they should have, for at least 2021, 180,000 doses for patients. That means 180,000 packets to treat 180,000 patients. And when I say doses or packets, these are basically courses of medications that the patient would take over a 5-day period of time. They are trying to ramp up production, and they believe that in 2022, they should be able to dose 120 million patients. And of course, that's worldwide. The United States government has already purchased 10 million packets at a cost of $5.3 billion. And if you do the math, you'll see that it costs about $530 per packet. So you can see that the science shows that this medication can be very effective in the population that we're most concerned about in terms of hospitalization. I think the real question is going to be, how do we ration this medication that clearly we won't have enough of to treat everybody who comes down with SARS-CoV-2? So what we have here is a great addition to the toolbox for physicians to treat patients with mild to moderate COVID-19 as outpatients. A couple of questions still remain. Number one, does this work for Omicron variant? Pfizer has told us that the proteases in the Omicron variant are very similar to the previous ones. There hasn't been much change there. And they have internal data that indicates that this medication, PAXLOVID, is very effective and just as effective, indeed, with Omicron as it is with Delta and prior variants of concern. Another question would be, what happens if somebody comes in with symptoms that have been going on for 6 or 7 days? This medication is going to be given emergency use authorization for patients who have had symptoms for 5 days or less. And while it may be effective in those, we don't have the data. And as a result of that, and because there's probably not enough medication to go around for everybody with mild to moderate disease, patients who are outside that window will probably not receive this medication. So it's important to educate people that if they're having symptoms that are persistent, even up to 3 or 4 days, to make sure that they get in to be seen within that time window period. And along those lines, because we know that there's not going to be enough of this medication to treat everybody with mild to moderate disease, it's important once again to underline the importance of making sure that we are improving our health and our immunity at a time of this nature where Omicron is increasing in cases here in the United States and around the world.